About 3 decades ago, the existence of planets beyond our solar system was an enigma. However, technological advancements and scientific investigations have led to the discovery of more than 5,300 exoplanets in distant solar systems. Initially, our observations focused on large gas giant planets, but as we progressed, we identified smaller planets, similar to Earth. Over 50 of these planets have a mass comparable to Earth, while over 800 have dimensions smaller than half of our planet. Precise information about how many of these planets occupy the habitable zone, where conditions could allow for the existence of life, is still unknown. However, we are now beginning to discover complete planetary systems with more than one potentially habitable planet. We have identified at least one such system in our cosmic neighborhood, the Milky Way. Our galaxy hosts numerous densely packed systems, many with stars similar to the Sun. Planets close to these stars tend to be excessively hot, making them unsuitable for sustaining life. On the other hand, cooler and less luminous stars have a closer habitable zone. A notable example is the Gliese 667 system, which has 3 stars and is located only 23 light-years from Earth in the constellation of Scorpius. This stellar ensemble is the first recognized as a low-mass star, hosting various rocky planets with the potential to support life in its dubbed Goldilocks Zone. The main star, GJ667a, belongs to the K-type, with about 73% of the Sun's mass. It has a companion, GJ667b, also a K-type star, with about 69% of the solar mass. The third star, Gliese 667c, stands out as an M-type red dwarf, with about a third of the mass and radius of the Sun. Despite being significantly fainter and colder compared to the Sun, GJ667c has a diverse planetary system. Initially, it was thought that only 3 exoplanets orbited around it, but recent studies suggest the possibility of up to 6 planets in the system, with 3 or even 4 of them potentially offering conditions suitable for life. But what exactly does a super-Earth mean? This term is used to describe a planet larger than Earth but not as large as gas giants like Jupiter and Saturn. These planets may be composed mainly of rock or a combination of rock and ice, and they may have atmospheres conducive to different forms of life. In the Gliese 667 system, the closest planet to the star, Gliese 667cb, has an extremely high temperature of 200 degrees Celsius. Being the most massive planet in the system, with about 5.5 times the mass of Earth, it is likely to have a dense atmosphere and completes an orbit around its star in just 7 days. The 3 potentially habitable planets in the Gliese 667 system are all located at a greater distance from their host star. With masses ranging from 1 to 5 times that of Earth, these planets stand out as strong candidates for the existence of life. Gliese 667cc, the second planet, is closer, orbiting on the inner edge of the star's habitable zone. With a mass 3.8 times greater and a size 1.8 times larger than Earth, this planet lasts only 28 Earth days in a year, with a similarity index to Earth of 8.85. This finding is considered remarkable among planets outside our solar system. Due to the low energy emission from the red star GJ667c, the habitable zone around it is located very close, ranging from 0.11 to 0.23 astronomical units. For comparison, Earth is positioned approximately 1 astronomical unit away from the Sun. If our planet were too close to the star, it would freeze. However, GJ667cc completes its orbit around the parent star at a distance 8 times smaller, taking only 28 days for a full revolution. This suggests that the planet is likely gravitationally locked, with one side permanently illuminated and the other in constant darkness. The significant temperature differences impact the global climate of the exoplanet. Gliese 667cc receives about 10% less light than Earth from the Sun, but most of this light is infrared, aiding water retention on its surface, resulting in a climate similar to Earth's. Due to uncertainty about the planet's atmosphere, we cannot accurately predict its temperature. Scientists are continually researching to obtain more information about this fascinating exoplanet. These discoveries are exciting as they demonstrate the existence of other planets beyond our solar system that may be habitable. As we advance in technology and research, there is an opportunity to explore and deepen our understanding of these distant planets. This not only expands our knowledge of the universe but also prompts us to question the possibility of extraterrestrial life. If this planet had an atmosphere similar to Earth's, heat would be distributed evenly, resulting in pleasant temperatures of around 30 degrees Celsius on the night side. Living on such a planet would be a completely different experience from what we are accustomed to. Gliese 667cc receives a gentle red light from its star. The other two stars, Gliese 667a and b, are located at a great distance, about 230 times the distance between Pluto and the Sun, and have no direct influence on the planetary system. The other two suns would still be visible as a pair of bright stars during the day and would shine as brightly as the full moon at night. Fortunately, the nearby red star emits intense bursts of radiation and significantly stronger energetic particles than our Sun. This could be a challenge for any potential life on the surface of Gliese 667cc, as the planet is situated close to this erupting star. Additionally, the strong magnetism of the red dwarf may cause stellar spots, reducing the star's energy production by up to 40% for months. This, combined with the lack of ultraviolet light emission, would be an additional challenge to the existence of life as we know it on that planet. Atmospheric pressure would depend on the specific composition of their atmospheres, which remains unknown. Despite the uncertainties and challenges associated with the planets of the Gliese 667 system, scientists persist in their interest to study them. Their quest aims to discover the possibility of life beyond Earth, seeking to understand the unique conditions these planets may possess. However, life as we know it may not be viable due to the low temperatures of these planets. If these worlds have a thick atmosphere, it could, however, be beneficial for the existence of life, providing heat retention and favorable temperatures. Identifying 4 potentially habitable planets in the habitable zone of the Gliese 667c system is a rare and challenging discovery. In 2013, astronomers found at least 6 around Gliese 667c, and there is the possibility of a 7th planet called GJ 667ch. The existence of the latter remains uncertain, as it would be too hot to sustain life due to its proximity to the parent star and its high temperature. However, planets Phae and possibly D are confirmed or suspected to be in the habitable zone. This is exciting, indicating that Gliese 667cc, CE, and perhaps CD have suitable conditions for life. The revelation of the planetary system orbiting Gliese 667c, a star classified as M-type, points to a more significant prevalence of densely compacted planetary systems than previously estimated. Since M-type dwarfs are quite common in our cosmic vicinity, it is plausible that many other promising planetary systems exist in our galaxy. Now, scientists can focus their efforts on individually examining stars for multiple candidates for Earth 2.0. This development underscores that our ability to unravel the mysteries of the universe is progressing rapidly. Stay informed to be among the first to learn about the next major discoveries in the cosmos. If you enjoyed this content, don't forget to click the like button. Subscribe to the channel and activate notifications by tapping the bell icon to not miss any of our videos. Thank you for following along, and check out other available videos as well. We hope you enjoy them, and until next time.